All right, so we should be on this page. I said last week that we have one more quadrilateral to talk about, and that's the trapezoid. We're going to talk about the trapezoid tomorrow. So today we're going to kind of still stick with this family of quadrilaterals that we went over last week, parallelograms and rectangles and all that, but we are going to talk about proofs today. Now, you're not going to be writing proofs like what we did last unit with all those triangles where we did some in class and then you had like a whole worksheet dedicated to writing proofs. You're not going to be doing a ton of that, but we're going to go over some proofs that are kind of important to understand why certain things do what they do inside of parallelograms and these other shapes, so that if we ever needed to take it that step further, we would have some of these things done. This is very similar to like when we proved why vertical angles work. Once we were able to prove that, then we never had to go back and prove it again. We were able to just use it to help us out in problems. So that's kind of what we're going to look at here today. Now, on this page, there's two proofs here, but if you look at what they say, or even what they look like, I'm just going to kind of zoom out. Do these look like they're the same parallelogram? Yeah, it looks to me too like they have the same diagonal constructed in here. And it even says that up above. It says underneath the proof statement, construct an auxiliary line that is diagonal to BD, or that is diagonal BD. So they did that for this one and they did it for this one. Just like last unit when we were proving why the angles inside of a triangle add up to 180, we had a parallel line constructed. We're going to use that construction to maybe help us out here. Now, if you look at what they want you to prove, the first one says, prove that opposite sides of a parallelogram are congruent. And number 2 down here wants us to prove that opposite angles of a parallelogram are congruent. So we're just kind of proving two different things, but we're on the same shape. Now, I'm pointing that out to you guys because as we get going with our proofs here, we're going to kind of see that a lot of the steps that we do are going to look the same for these two proofs because we're working with the same parallelogram and it has all the same pieces inside of it. But let's focus on this one to begin with. Now, when that diagonal was drawn in, guys, what did it cut that original parallelogram into? Triangles. Two smaller triangles, right? Do we know that these two smaller triangles should be the same? Because didn't you guys do that last week where you had one of these triangles, you rotated it to get the parallelogram to show up? So we kind of already have this understanding of we know that those two triangles should match, but we need to be able to prove it now. So this is when we get into like, how do I actually justify all those things that we were doing last week? So I'm looking at these as two triangles that are kind of overlapping there in the middle. We have written triangle proofs before, so let's use some of that information and knowledge from the last unit to help us do this. So I probably want to try to show somehow that these two triangles in my picture are congruent to each other. So I need to get to one of those 5 tests: angle, side, side, side angle, side, angle, side, or angle, side, 1, side, 2. Like one of those 5 tests is going to let me know that those two triangles are congruent to each other. If you look down here, they already have the given written out. They're saying that ABCD is a parallelogram that's given to us. Last week when we talked about parallelograms, what word is inside parallelogram? Parallel. So if there's parallel lines in the picture, what are we looking for? What did we look for on triangle proofs anytime we had parallel lines? Angles. What kind of angles? Do you remember? Not supplementary. What'd you say? Someone said it. Yes, we were looking a lot for alternate interior angles. Okay, so I know I have parallel lines in here just because we know that this is a parallelogram. And so let's identify those parallel lines. What sides on your parallelogram up here, using letters, how would you name them? What sides are parallel to each other? A, B, and DC. So I'm going to write that down first. AB is parallel to DC. And what else? And we know that because that's what parallelogram means. Now I'm going to focus on the parallel lines B, C, and AD only because that transversal that I'm noticing right now is the diagonal B to D. And so if I have parallel lines and there's this transversal in there, that's going to probably help me see these alternate interior angles that we want. So I'm going to come on here really quick and I'm going to just kind of highlight over those parallel lines. And then I'm going to draw in another highlight over that transversal. Okay, I'm just going to zoom in on this picture really quick. If those are my parallel lines and my transversal, where would the alternate interior angles be? Colby?
Angle CVD and angle AD.
So like this one and this one are the ones you just named, yeah?
Yep.
Okay, and then would these other sides also be alternate interior angles? Yeah. Now, I love how you named those with the letters. That was perfect. I'm going to have us add something to the picture to make this a little bit easier on us so that we don't have to do it with all the letters. Because if we do it with all the letters, we have to say, CBD and then ADB, which is what he just said. But then I also have to name the other set, which is more letters. And it's sometimes just kind of like a mouthful when you're talking about all these angles with all the letters. So here's what I want you guys to do. On your parallelogram, I'm giving you guys the liberty here. You can add numbers into these corners. So I'm going to call this 1, this 2, 3, and this 4. We're just going to add those in to help make naming these alternate interior angles a little bit easier on us so that we don't have to do all the letters. Naming it with letters is not wrong, okay? So if you wanted to go that route, you can. We've already spent a lot of time doing that, though. So I'm going to let you guys kind of do this to give yourself a little bit of a shortcut here. So now, instead of saying angle like CBD, like Colby was saying, I'm going to say angle 1. And then that would be congruent to what number? Angle 4. And then what other numbers can we say are congruent? Good, 2 and 3. So I'm going to go ahead and write that down here now. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Because like I said, these are alternate interior angles. Okay, and then I'm going to go ahead and mark those angles on my picture too. Now you can use arcs if you'd like to, or you can just use symbols. If you use arcs, the only thing is that you might cross over those numbers that you had, but that's fine. So like if we call 1 with 1 arc and 4 with 1 arc, and I'm going to give 2 arcs to angle 2 and angle 3. You don't have to use those though. You could do like open circles, closed circles, stars, whatever you want to use to kind of show that those angles would be matching. Okay, so that got me 2 pieces so far. Now, in order to show triangles are congruent, though, I needed 3. So I need one more piece of information. Does anyone see where it might be? If you think back to when we did these in the last unit, this would be when we start to look for anything that they share. Do those 2 triangles share anything? What side? BD.
Congruent to BT for reflexive.
Very good. And then I'm going to go ahead and mark that side with a dash. Okay, so now let's take a look at what we have marked. If I start here, this is an angle, and I go towards my marking side, angle, and then up here, angle, side, angle. Is that one of our 5 tests? Yes, it is. So we should be able to say that these triangles are congruent to each other. Now, when we name the triangles, let's be careful. If I say triangle A, B, D, how would you guys name the other side? Perfect. We have to make sure we keep like markings together. So the A and the C, both of those have nothing marked on those angles. And then I know it looks like the D and the B should be switched, but we're looking at angle markings right now. So I'm putting the two arcs together and the one arc together as I kind of follow around my triangle. So that's why it should be CDB on the other side there. And then we said that was using angle, side, angle for my test. Okay, now that I have those two triangles are congruent, that means that everything about these two triangles should match, even if it's not marked. So like those other angles, A and C, or the sides that are BC and AD, or even the left and the right sides of my shape, those are other sides of my triangle that I should be able to say now are congruent to each other. And they want me to prove that. Like they want me to prove that the opposite sides on the picture are congruent here. So up here where that proof statement is, I'm going to go ahead and copy that down. AB is congruent to CD, and AD is congruent to CB. Any of you remember what that thing was that tells us we can do that? Very good. CPCTC. Remember that stood for corresponding parts of congruent triangles are congruent. So that tells us if you have congruent triangles, everything about them should match. So that's why we're able to say those other sides that we don't have markings on should be congruent. And in the overall big picture of our parallelogram, that's proven that those opposite sides of the parallelogram would be congruent to each other. Okay, now if you remember what I said at the beginning of class, this second proof is very similar. What's the one thing that changed? The proof. What do they wanted me to prove on number 2? A and C are congruent to each other. That is the only thing that is different here, okay? So what we're going to do is every step that we wrote up above on this first proof is still going to apply to this shape down here. Step 6 is going to be the one that changes just a little bit. So if we look at our shape down here, I still have parallel lines. Like this is still parallel to this. I still have a transversal. And I can still name these angles 1, 2, 3, and 4 to help me out. But if we go back to kind of what we saw in that last problem, we talked about how alternate interior angles would be congruent to each other. So that's still 1 and 4 and 2 and 3. And we still have a shared side, BD. So we're still going to be able to say that these triangles are congruent using angle, side, angle. So I'm going to take just a couple minutes here, and I'm going to copy down everything that we wrote up here, steps 1 through 5. I'm going to stop there because I'm going to talk about what's different about step 6. Okay, so we copied everything down. The only thing that you have to change here for step 6 is what we're trying to prove. Because on the last one, we were trying to prove that opposite sides were congruent. Now we're proving opposite angles were congruent. And so up here, my proof statement says angle A is congruent to angle C. Those are the specific opposite angles that they were talking about. And we're still using CPCTC to justify that. All right, now that we've talked about those two things, going forward, anytime that we're maybe trying to justify something about a parallelogram or any of these other shapes that we talked about, we can use that information to help us out. Because we said last week, rectangles, rhombus, and squares, all three of those shapes are also considered parallelograms. So all of these properties that we just discussed are also going to apply to those other shapes as well. If you guys turn your page over, we've got a couple more here on the back, but you guys can cross off number 3 because we're not going to do that one. So we're just going to do 4, and then we're done. What shape are they giving us this time? A rectangle? And they want us to prove that the diagonals on the rectangle are congruent to each other. The diagonals would be those sides BD and AC, kind of connecting opposite corner to opposite corner. Now, they already kind of got our proof started for us again. They have given us our given information, which is the fact that ABCD is a rectangle. And then underneath that, they got us another step already. It says that a rectangle is a parallelogram because of the definition of a rectangle. And again, we talked about that last week. A rectangle is always considered a parallelogram because it shares all the properties that a parallelogram has. Opposite angles being congruent, opposite sides being congruent, all that stuff. Now, the diagonals in a parallelogram were not congruent to each other, which is why we're trying to prove that they are in a rectangle. But we still want to try to kind of use a triangle proof to help us do this. Now, the triangles in this picture are maybe a little bit harder to see because they overlap a little bit. So I'm going to be isolating 2 different triangles here. I'm going to be looking at this one that goes from B to A to D. So I'm trying to go over that one kind of in purple. And then the other triangle is C to D to A. So I kind of went over that one in like a reddish color. If that's too confusing for you, you can separate these out, even just underneath your picture here. That might help some of you like know what I'm talking about. And I'll even go over this one in purple just so you kind of get where I got that from. And then this one down here would be my orange triangle. Okay. If we know that a rectangle is a parallelogram, because that's what we said in statement number 2, then that means we know something about opposite sides because we just proved that opposite sides on our parallelogram were congruent. So opposite sides would be congruent on this shape too. That means that the side like BC and AD would be opposite and they would be congruent. And BA and CD would also be congruent because they're opposite too. Now I'm going to be a little bit strategic in which ones I pick because if you look at these triangles that I drew down here, the only pair of opposite sides that I have are BA and CD. I'm not really focused right now on the top and the bottom. So I'm going to go ahead and just state for my next statement that BA and CD are congruent to each other. Because of the definition of a parallelogram. And like I said, that's what we just proved on the back side of this page. We proved that opposite sides of a parallelogram are congruent. So that's why we can say this now. So that means that those sides, B, A, and C, D, should get marks. So you can do it on either one if you drew the triangle separately or if you're looking at the same picture up from up above. These sides here, this one and this one, I'm going to give them each 1 dash. And I'm going to do that on both sets of my pictures here, just in case you did split it out and you want to kind of keep track of what's going on. Okay, let's talk now about like the corners. And it might be even easier to see these on my separated triangles. Like this corner, the whole corner by A. So like all of this, ignoring that diagonal mark. And then over here, that entire corner by D. How much do we know those corners are since this is a rectangle? We know that they're 90. So I'm going to go ahead and say then that those angles have to be equal to each other. Now I'm not just going to say A and D because it's a little bit confusing with our two separate triangles here. So I am going to name this angle BAD. And the other side I'm going to call it CDA. And I'm going to just write right angles are congruent. Okay, I've got that marked now on the original picture and on my triangles down here that I separated. So now if you look at those two triangles and even just maybe look back up here at the combined picture, I need one more piece of information in order to say that those two triangles are congruent. Is there anything that they share? AD? That bottom piece is shared. I overlapped it with my highlighting up there. That's kind of where the purple and the orange overlap. And even if I look down at these separated pictures, they both have this side AD on both of them. So that segment is being shared. What property allows us to say that it's congruent to itself? Reflexive. So I'm going to go ahead and say AD is congruent to AD because of the reflexive property. Okay, I'm going to mark that. I'm going to give it 2 dashes here. Do we have enough now to say that these two triangles are congruent?
Yes.
Okay. What test are we using now? Good. And if I say triangle BAD, what would you guys say? Good. CDA. Okay, so now, if we know the triangles are congruent, now isolating or looking at these diagonals, B to D and A to C. Those are these sides that I don't have marked on my picture. But again, these triangles are congruent. So what allows me to say that those diagonals have to be congruent?
CPCTC.
Very good. C, P, C, T, C. Okay, would you guys like the bad news or the good news first? Okay, the bad news is you need to start working on memorizing these proofs. Because while you're not going to be writing proofs from scratch to prove things on quadrilaterals, a couple of these, 2 of these, are going to show up on your test. I'm not going to tell you which 2. You need to be able to know. Now the first 2 are really similar to each other. So really they count to me as 1 because you have to memorize those first 5 steps and just know the 6th one changes based on your proof statement. And then you have this one. The good news is you don't have any homework today. So you can maybe use some of your class time to kind of read those proofs over again. And then just know, going forward, we should probably make sure that we're going back over our notes. Because when is our test? Friday. So by Friday, I'm hoping you're going to feel really comfortable with those proofs that you've got them memorized. Okay? I'm trying to give you plenty of warning so that you don't show up on your test day and you don't have anything that you can write down from those proofs. Okay? Questions on that?